Hi everyone, in the past few videos we've deployed a cluster, we've deployed a database, and a DB migration. In this video we're going to deploy a .NET API right into the cluster. This API will connect to the database and we'll be able to register a user. So without further ado, let's get started. Alright, we don't need to be looking at K9s. Let's switch over to Writer. I want to show you the API that we're going to be deploying. So we have our API, you might have seen this in the last video, and then we have our data project. This is all inside one solution. And of course, we have some spare files up here. So we're going to take a look at the Dockerfile in a moment. But first, I want to just show you what's in here. So we have a solution, then we have an SRC folder in which our projects live, and the SQL folder in which our DB migration lives, which you could see in the previous video in this series. So let's see what steps we need to do. Well, it's actually really quite similar to our previous deployment with the DB migration. What we need is we need a Dockerfile. We need to build that Dockerfile and deploy it into our cluster. And then we need to install a Helm chart, which has that deployment in it. So pretty straightforward. Let's get started with step number one, which is building the Docker image. But before we can do that, I want to just briefly take a look at the Dockerfile. I like to have my Dockerfile smaller, so I've deleted some steps that are auto-generated by the IDE. You can see here in the first step, we're pulling from the SDK image, and we're doing a .NET restore, okay, getting all the NuGet packages. Then the same image, we're not pulling from any other image or creating another layer. We're doing a publish to this output folder over here. Again, nothing out of the ordinary. And then we have the Alpine image that we're using here. There are a couple packages that we need to install. Well, actually just one package, the international components for Unicode. So we want to install that into the very, very bare bones Alpine image. We said we disable the invariant mode, so this doesn't seem to work. I've tried using this in Alpine with .NET. I wasn't able to start up my project, so I found that this is the solution that fixes this. Hopefully it doesn't break anything else, although I did test my API. It seems to be working just fine with this environment variable disabled. And of course, then we're doing the expose for the ports. We're copying everything from the publish folder, which you can see right here, and putting it into our /app/publish folder. And then this is the entry point for that Docker image. So it's really very straightforward. The only thing that's different are these two lines over here. So now that you know what the Dockerfile looks like, let's go ahead and build that Dockerfile inside of our cluster, just like we did with the DB migrations previously. All right, so back in the terminal, we do need to execute that one line, which lets us run all the Docker commands against the Kubernetes cluster. So I'm gonna grab it over here from the website. I'm gonna paste it right in here. You can just press enter. You'll see nothing, but that's okay. And then last thing we got to do is just got to build the image. So we are already in the API directory. If we look what's in here, we have our Dockerfile right there. You can see. So all we're going to do is we're going to say Docker build, and then we're going to tag it. So we're going to call it homey. Let's just say homey API, and then with the latest tag. And of course, it needs to know what we're building or where the Dockerfile is. So we're already in the directory. We can just press dot, press enter, and it built. It's done. We're good to go. So if we go Docker image list, we see that we have homey API with the tag latest, and it's ready to go inside of our cluster. You can also see we have the DB migration as well as Postgres in there as well. So, all right, we're all good here. Let's take a look at the Helm chart. All right, over in Visual Studio Code, we're looking at the Helm chart for homey API. It's a pretty standard Helm chart. You can see here we have chart.yaml. It just has some standard metadata, and then we have our values. We're gonna go over these values while we're looking at the deployment, but we have the standard namespace, app label, as well as the image and the tag that we're pulling. And then we also have the username and the password for the database. We also have the DB name And then we have the replica min and max count, which is essentially how many instances of the .NET application we want running inside our cluster. So let's take a look at the deployment first. All right, here's the deployment. Again, much like the Postgres deployment, it is a kind of deployment. We have our metadata, pretty standard over here. And then we have the spec. There's a couple new things here, right? So we have the strategy. So the strategy of rolling update is essentially, if you're doing a rollout restart on your application, this is like you want to restart your application. Maybe something broke, or you want to maybe pull the newest image. You want to do something called a rollout restart. But what that does is it could potentially leave you without an instance of your application running. So a rolling update, what this ensures is that you always have one instance of your application running. So it never like turns off, then there's nothing, and turns on. It starts up one more extra, then once that's ready, then it turns off the old one, right? So that's what the strategy is over here. And then under template, this is a template for every single pod in this deployment. The container that we're using, as you can see here, we're referencing the image and the tag from the values file we looked at before. Then we have the image pool policy, and then the port on which the container is listening. So we did define 8443 for SSL, as well as 8080 for regular HTTP. Most of the time, and I say this with a big asterisk, most of the time you're gonna just use port 8080 for your .NET applications, because you're gonna be terminating SSL at the ingress level, and we're gonna look at ingresses in a future video. So you're gonna terminate SSL there at Nginx, and then you're going to forward all the traffic over to port 8080 over here. But in some cases, you need to run your .NET service on an SSL port, 8443 being the default, in which case you will want to add another entry here for SSL. If you're interested in seeing how that's done, do let me know in the comments below. I can create a video on that. It's a little bit more advanced because you have to generate a certificate and all this other stuff, but totally doable. So we have a port here of 8080 where traffic is going to be going, and then we have our environment variables. So we have two types of environment variables defined here. First, we have like the one you've seen before with env, then the name of the variable, and then where we're pulling the value from. So we're pulling it from a Configmap of name global config, and then the key we're looking for is ASP.NET Core environment. So this is going to say like production or development or something. And then we're pulling, again, container HTTP port. If you want to see where these values are, they're actually up in here. So this is the global config, and then we have the ASP.NET Core environment, as well as the HTTP port of 8080. And then we have the next part, which is envFrom. So this is kind of a shorthand for pulling all the environment variables from the Configmap reference. And in here, we're saying, hey, pull it from the Homey API config map. So this essentially is going to take all the key value pairs from here and put them into the environment variables in the deployment right here. So looking at the config map, all we really have in here is, well, we have the default stuff like connection strings and logging information. And then if you might have seen my video for how I built the Homey API, I think card up above if you want to take a look at that. We also have an SMTP service that we're running for sending emails. So I've defined some default data here. This is all fake. Obviously, you'll want to store it in a secret potentially, but just to get the app, up and running in the cluster, I've defined them all here as environment variables. You may also want to set them up in here, just like we did here. So you either pull from a config map or you pull from a secret. In fact, you should probably pull from a secret for specific things like username and password. So you can do that, but we are pulling them from environment variables in this deployment, and all these environment variables are right here. So that's the config map that gets parsed into environment variables. And then lastly, we have the readiness probe. The readiness probe essentially says, hey, this service is only going to be marked as ready in Kubernetes when I get a 200 OK response from this endpoint, this /health endpoint at port 8080, right? Because that's where we're running it right here. Now, you can, of course, run on a different port for the health check. I don't know why you would, but you could do that. And if we successfully get a 200 OK just once, then the service is considered to be OK. So that is the deployment. I know it's quite a bit of text in here, but I tried to actually extract the environment variables into their own config map. Otherwise, this would have been even bigger. But let's take a look at the two other things that are in here. First, we have the horizontal pod scaler. So what this does is it says, hey, essentially, I want to run a minimum of one instance of this .NET application in my cluster. But if the CPU utilization for that one instance goes above 80%, then spin up another instance. And if both of those instances are above 80%, then spin up another instance. They're called replicas in Kubernetes. And if you recall, we defined the minimum. We want one at least running, obviously, right? And then the maximum, we want at most 5 replicas running of this deployment, of this API deployment. So if this is, for example, like a public-facing REST API, you will want to run multiple instances of it because there's going to be a lot of traffic, right, coming into that publicly facing API. So that is what the HPA is. It tells you the minimum amount of replicas running and then the maximum amount. And then you can also set not just metrics. I only have CPU in here, but you could also use memory, for example. So we're not going to go into too much detail about HPAs, but suffice it to say, this is what that does. It tells you about the replicas of that deployment. And the last thing we want to look at is the service. The service is very important because that is how you communicate with that deployment. Now, you recall Postgres deployment has a service as well. So if you watch that video, you already know what a service is. Specifically for Homey API, we are targeting port 8080, whereas in Postgres, we targeted port 5432 because that's where that's running. But, whoops, let me close that up. But publicly, we're exposing port 80, right? So we're not exposing 5432 or anything like that. We're saying port 80 is where the service is exposed. So we can just say http://homey API-service, and that's it. We don't need to add a port afterwards because 80 is the default port. So that is the service, and that is the Helm chart. Now that you've seen what the code looks like, let's go ahead and install this Helm chart into our cluster. All right, back in the terminal, we are in our Helm folder. So let's take a look at what we got in here. And we do have the new Homey API chart that we just looked at. So let's go in here. And then just as before, all we got to do is just say Helm install, call this something. So we'll just call it Homey API. And then of course, what we're installing. So we're already in the folder. So we're just going to say dot. Press that, and it's deployed. Now I do have K9s running, so you can see here that Homey API deployment is deployed, and you can see that it successfully started up. So if we go and we can press enter, we see that we have one pod, and again you can see the CPU and the memory default requests and limits are set right here, and we see that we have exposed this on port 8080. Now if we press enter one more time, you can see here that we are hosting on 8080. We're now listening on port 8080. The hosting environment is production, and you can see that the health checks are being requested over here. So let's exit out of here. Now that we have our deployment up and running in the cluster, we cannot actually talk to it just yet because we do not have an ingress. That is going to be the next video that we're going to be covering, the ingress. But what we can do is we can do some port forwarding, and we can check to make sure that the deployment is actually working as intended with the database. So press Shift F to do some forwarding. And what we're going to do is we're going to have the container port be 8080, and we're going to say on our local host, we also want port 8080 so that when we're using Bruno, which we're going to look at next, to connect to this API, we're going to select port 8080 as our port. So let's press OK, and you can see that the bottom port forward is activated. Let's switch over to Bruno, where we're going to register a user just to make sure that the API is working as intended. All right, so over in Bruno, you can see that we have the register user endpoint open, and it's pointing to HTTP at port 8080. Now recall, it's HTTP because we don't have SSL set up yet. We're going to do that in the ingress video, and it's at port 8080. The body we're sending is jillv@umbrella.com. Bonus points if you get the reference, and email and password. Really, that's all we're sending. So let's go ahead and send that over and see what we get. And we get a 200 OK, which means the user was created in the database. Now, I've already port forwarded Postgres, so we can pull up pgadmin, which we have over here. And I have it prepared in the interest of time. We don't have any users right now, but if we execute the script to press play over here, oh, we see that we have a user that we just added, jillv@umbrella.com, which you can see here. So we hit our API, which then connected to our Postgres database in the cluster and created a record in the database, which you can see here. Pretty legit. Looks like we have an API up and running in the cluster. In the next video, we're going to install a certificate, and we're going to install the Nginx ingress controller so we can see our API and hit the endpoints without port forwarding. So stay tuned for that, and I'll see you in the next video. Take care.